Hi guys, welcome back to my channel. So today quote is, our greatest glory is not in never falling, but in rising every time we fall. So just keep rising and just let's start the video. Yeah, so far we have discussed about the stream API, and today we discuss more about not exactly the stream API but another API which is called the parallel stream API. So let's start it. First, as you all aware about this, I'm just declaring the nums array. Perfect. And suppose now I would like to tell you that I want some 10,000 size of array. How can I do that? Yeah, basically you just mention here 10,000. Yeah, this is the initial capacity and you get it right. But there is some other way. Yeah, this can also be used. Here the underscore basically represent the comma when we are talking numbers. So just mentioning here the size. Oops. Yeah. Now I want some 10,000 numbers, so how can I do that? By using some nums.add. No, I think this is very poor technique to add 10,000 numbers. So we want something like someone generate us for numbers and add it into the nums. So there is a function in Java, random ran, which basically generate random numbers, but this will gives one number, but we want 10,000s. How can I do that? So as I've already described earlier, so when you have done with some iteration and you have to automate that particular task using for loops. So I'm just declare some basic stuff, and the size, and there's a function in random which is next int. Yeah, here it is. Basically it gives next integer every time, and suppose we want our next integer, the upper bound we set is 100, or you can set, you can 10, you can 1000, you can 10,000, but for our use case we use some 100. And how we use that? This is the upper bound. Let me just open it. Have you seen that it is bound? It consider a value bound, which is the upper bound, and it must be positive. Yeah, so basically this generates some an array of 10,000 numbers with different values. So let me just print it to check it is correct or not. What is nums? So let's compile it and then run. Oops, it's empty. Why? Because we haven't done nums.add. So just do it, nums.add, and then put this hole inside this. Yeah, you got the 10,000 numbers, different numbers. Cool. Now in the previous lecture we used some stream, and in the stream we perform the operation doubles the value and then submit. We're going to do that. First, you all know that first we create a stream class, and then in the previous lecture we just sort with the odd numbers or even numbers, but today we just consider all numbers. And simply double it, and then we use some reduce function. As you remember, the first is the carry, and then second is the code, the logic, simply C plus E. Yeah, that's it, and just check it. What's the answer? Yeah, so you got some 9,93,024. Okay. Yeah, this is so far we've discussed, but let me show you one thing. Let us again do that stream, then map to. What if, guys, we have sorry, I think just, yeah, I just want direct to sum, not to reduce or some, then put our some logic. I just want give me the sum, but it doesn't have sum right now because we are working with map. In the current stream, our latest stream is the map. So how we get to integer? So there is a function in Java which is mapToInt. It basically gives the map stream to an integer, and the operation we are not performing any, just convert it into, take another map and convert it into the num or integer. And how you know that it contains some function? Just open it, and it uses the object of int stream as you've seen here. Just open it. Okay, and let me just find it. Yeah, here you're seeing that the sum is present, which return the sum of elements in this stream. Okay, pretty cool. Just use it, and it is showing here now. And to check our result, we print both the sum to check whether the new code or the new changes are working fine or not. If our both output is same, then it means it will be correctly fine, and we use it further. Yeah, here you've seen that both numbers are same. That means we can use this sum to, or the second way of using the sum method in the stream is correctly fine, and you can use it further. Okay, guys. Now this all about the streams. Now what I am trying to teach you today is the parallel stream. Okay, so just, there is nothing rocket science in this. Just copy paste the stream logic and just convert into parallel stream. Let me change the some third and checking this working fine or not. Basically I'm just trying to fit, and all the three sums are exact same. If it is same, our output is same, then it will be fine. Yeah, here you seeing that both the three outputs are same, exact same. Okay, so both are same. So what is the need of parallel stream? If the stream is correctly fine, why do we need the parallel stream? Oh yeah, great question. So let me just remove this and focusing only the new methods. Just get rid of this. I think I'm going to do this. Yeah. Okay, so now till that point we have sum 2, sum 3, sum 2 using the stream and sum 3 using the parallel stream. Okay, and we got the same output. Okay, so let us try something, you know, to calculate how much time the stream takes and how much time the parallel stream takes. Before doing that, I would like to tell you about the stream using single thread, while this parallel stream is using multiple threads. Okay, so as a, you know, just a normal scenario, you consider which one would take less time, a stream or parallel stream. Basically it depends, because sometimes your single thread is fast enough, but in the parallel stream it will creating multiple threads and then execute the task. So sometimes the creation of multiple threads take more time than individual single thread perform the same task. Okay, let's first we calculate it. So there is a method in this current time millisecond which gives the current time in the millisecond. So I put it here, so it gives the start sequence, and then I just put it some end sequence, so it will give me the end of the current millisecond. In the same way, I would like to do for this, to calculating the parallel stream, how much time the parallel stream takes. So this is the this is the first starting timer, and this is the ending timer. Okay, now just calculate it. First print the sum, then just for sequence, let me just write it here, the end sequence minus the start sequence. Basically it gives the time duration from start till end, so it will give you the exact time for a single stream to work or to perform operation. And when I'm calculating the value of parallel stream, it will gives you the how much time or the exact time it will take for the 1000 iteration to work with. So let's just use for para okay guys, everything is ready, so let's just try it. Yeah, as you've seen that the both sum is same. Sequence takes 7 milliseconds and the para takes 3 milliseconds, as it will be using multiple threads. Okay, so this will show you that parallel streams are fast. Okay, now one more thing is there is not much big difference. As I'm running multiple times, there's not much big difference. Okay, so let's create some delay in the sequence threads and parallel threads, so then we know how much exact time it will take when one operation take 1 milliseconds of delay. So how do we create delay in millisecond for each one operation? Okay, so let me just, so as you know, when you are writing multiple codes, you have to use the curly brackets and then return, and before that use some try catch block, because I am using some Thread.sleep to create delay of 1 millisecond. In this and in the parallel stream also, to check whether it will be working fine or not, or it will be working fine then how much time it will take in both the sequence and parallel. And here you know why parallel streams are sometimes better when your operation or the values are not dependent on operation. I think everything's fine. Let's write it again. Yeah, it will take time because I'm creating some delay. It will stop it and then some computation and then just throw the result. Okay, guys, I'm also waiting just like you're waiting. Here you see the drastic changes. The both sums are, I think, yeah, nearly same, but the sequence take 12,000 milliseconds and the parallel stream takes only 1500 milliseconds. So now you got the difference why parallel streams are fast in but some cases when we are dealing with our operation and our values are dependent on operation, then we are using parallel stream, and if they are independent then we will use sequence. So now you let me just recompile it and you check it. Again, it will take time because I'm just creating some delays in both the doubling operation, and after delaying then it will compute computation. Now the sequence thread, why it will take more time, because there is only one thread, and when I stop it, it will double one value and it will stop, and then will again double the value and it will stop. While in case of parallel threads or parallel stream, it will creating multiple threads. If one thread stop, the others are working fine. So that's why the drastic difference. So that's it for today, guys. Thank you.